Hello everyone, welcome back. In this video, I'm gonna talk about how to contribute to AWS CDK, and I will demonstrate a real CDK contributing experience by create a CDK pull request from a real issue and help you guys walk through how to make and submit your first CDK pull request. So if you are interested, we actually have a CDK contributing guide in our CDK GitHub repository. So just go to the AWS CDK GitHub repository, go and scroll down all the way to the contributing markdown document. Click into the document, and we actually talk about how to help you get it started, including how to find something you can work on with, and how to prepare your IDE, all the tools you have to install, especially the development tools and the CLI. If it is your first time contributing to AWS CDK, you probably will notice that it's actually not easy to prepare your local IDE environment. So in this video, I'm gonna introduce something I really love. It's called Gitpod. So Gitpod is a SaaS service help your development in an online IDE. Behind the scene, the GitHub actually create a workspace. I believe it should be in a containerized workspace to help you have an ephemeral IDE. So why I think ephemeral IDE is important is because that it is very great because all your development tools or configurations is actually pre-configured and bundled in the ephemeral IDE. You can simply bring up this workspace, jump into this workspace, and start your hacking. And if everything is good, and you just submit your PR and just close your IDE. Online IDE will just be destroyed and nothing left. So it's pretty good to help you getting started very easily without installing everything in your local laptop. In this video, I will show you how to get it started with Gitpod. And after we bring up a GitHub online IDE, we will connect with our local VSCode IDE. So in this case, actually the UI is in our local IDE, but actually the IDE instance is actually running remote on the Gitpod data center or on Gitpod cloud. Okay, let's get it started. So if you are new to Gitpod, so Gitpod is actually a SaaS service that help you to create a free online IDE to help you develop any your application or software. And it is great when it is integrated with GitHub. So actually the GitHub has some browser extension to help you simply click a button and bring up a temporary IDE to help you to work with the GitHub repository. So just Google search Gitpod browser extension and you will see this page. So and in this page depends on different browsers. So in this at this moment Gitpod support different browsers like Chrome, Firefox. I personally prefer Brave browser, and actually Brave browser actually share the same extension with Chrome. So you can simply install the extension from this page. And after you install the browser extension, you will see an additional Gitpod button. So by simply click this button, you will be redirected to a Gitpod workspace IDE, and it will just bring up a standalone workspace for you and clone all the source code from that repository. So you can just start your hack with the existing source code. Okay, so I will skip this phase as I have already installed the extension, right? After you install the Gitpod extension, simply go to the CDK issues, and you can start looking for something you are really interested to work with. So in this video, I'm gonna work with EC2 metadata. Okay, so there's actually a request to add support for metadata options in launchTemplate. Okay, so if we look at this issue, actually, the community is asking for some metadata option support in the existing L2 construct of the launchTemplate. Okay, and this issue is at this moment identified as P2. So P2 is not as high priority as P1, but it is very great for all the community to work on with. So I'm gonna so in this video I will try to create a PR for this issue, and hopefully you guys will know how to get it started with similar PRs like this. Okay, personally will just leave a comment like this, for example, working on it, to tell people that okay, now I'm working on it. If anyone also interested, let me know. Let's avoid potential conflict. Okay, so this is something missing, and people was asking to add for the L2 construct. So if we scroll up a little bit, so actually this is a launchTemplate L2 construct, and this is the construct class. Everything in this construct class is how it was implemented. Okay, so if we scroll down a little bit, okay, so this is the primary L1 resource being created within the L2 construct. So L2 construct is basically a construct class that help you provision the L1 construct. So all the L1 constructs will start with the CFN prefix like this. So this is basically a L1 construct class that actually synthesized into the CloudFormation resource. So in this case, what we need to do is that we have to implement the metadata options here. Okay, so we just go to the document, the metadata options. So in metadata options, we actually have some properties like HTTP endpoint, HTTP protocol, IPv6, HTTP put response, hoop limit, HTTP tokens, and instance metadata tags. We have 5 properties to implement, and actually all the properties, 4 of them are actually string property, and 1 of them is integer property, right? And we can click into each property. For example, HTTP endpoint is something we can enable or disable the HTTP metadata endpoint on your EC2 instance. So if the parameter is not specified, the default state is enabled. So it's just kind of like a toggle to make it on or off. Simply enable or disable. The CloudFormation property type is actually string, but in CDK we tend to make it like a Boolean property to make it enable or disable, just like a toggle to make the experience better. So in this property, I probably will make it a Boolean type for CDK, like true or false. So you can simply turn it on or off, or enable or disable it. And similarly, in the HTTP protocol IPv6, I will also make it a Boolean construct property type. For the HTTP put response limit, just make it integer. And similarly, HTTP tokens Boolean, and instance metadata tags, I will also make it Boolean as well. We just need to introduce 5 new properties to the existing launchTemplate L2 construct. Okay, now let's go back to the issue. So if you have already installed a Gitpod extension, you probably will notice that there is a new button on the top right corner, a Gitpod green button. So you just click this button, so you will be redirected to Gitpod IO website, and a new workspace will be preparing and bring up for you. And this might take a few minutes because behind the scene, the Gitpod workspace will be provisioned, and it's actually a Docker container. So you'll see that it's actually pulling the container image and bring up everything as a container. So typically this will take just a few minutes. Okay, now the workspace is ready, pretty much similar to the VSCode experience. It's actually trying to YAML install and YAML build all the whole CDK repository, and this would take a lot of time. So you can simply just click the Control-C to terminate it. Okay, so now you are actually working on a remote IDE from Gitpod workspaces, and totally just in your browser, right? And everything required is already there, but you probably would be more comfortable with your local VSCode IDE. So now I'm trying to connect my local VSCode IDE to this remote instance. Just go to the top left menu, scroll down, open in VSCode, and click Open Visual Studio Code, and click Open. Okay, so now a new VSCode workspace will be created. So under the covers, actually the local VSCode is connecting to the remote Gitpod workspaces through the SSH. So if this is your first time to connect your local VSCode through SSH to the Gitpod, you probably have to define your SSH public key on Gitpod. So just follow the instructions so your VS Code can connect to the remote Gitpod workspace through the SSH. Just trust the authors from the repository. Okay, so now we are in the local VS Code, but actually the instance is on remote Gitpod. So it doesn't matter if you are working on Windows or Mac OS X, Intel or ARM CPU, doesn't matter, because actually you are working on a remote Linux containerized environment, but the UI is actually on your local laptop. So you'll see that actually it's a Linux environment, and you have AWS CLI and everything included in this workspace. Okay, so now we need to install the required tools for our development. So first step is just run the yum install. This will just install everything required for your development. So if you're interested about the Gitpod integration with CDK repository, you can just go to, you can just click the Gitpod YAML. So Gitpod YAML is a definition file, as a configuration file to define. So when people click the Gitpod button on the CDK repository, a new workspace will be created, and we actually use this JSII container image for this workspace. And on the workspace initialization, we actually will run the yum install and the yum build the whole repository, but this will take a lot of time. So we simply terminate that, and we can just run it by ourselves. So after yum install, you already have all the npm modules required installed. So now we need to identify which module we will start our PR contribution. So in our case, launch template construct is in the AWS EC2 module. So we just go to the AWS EC2 module, and we just build up our the AWS EC2 CDK module with all its dependency. right? We don't have to build a whole CDK repository. We just build the EC2 module with all its dependency. So in this case, we can just go to the packages and the AWS CDK, AWS EC2. Okay, so now we are in the AWS CDK, AWS EC2 module directory. So just simply run this, run the buildup script. The buildup script will build everything for AWS CDK EC2, for AWS EC2 module and all its dependency. So you'll see that there are 29 modules being built for AWS, including the AWS EC2 module, right? So this will take a few minutes. But you don't have to build the whole repository, which will just take a few hours in some cases. Okay, just after a few minutes, like 5 or 10 minutes, the EC2 modules with its dependency will be all built. So so now you are ready to start your hack with the EC2 module. So in our issue, we are trying to create more construct properties for the launch template, which is in the EC2 module. So we just go to the AWS EC2 module under the packages at AWS CDK, AWS EC2, go to the lib and check out the launch template. Okay, so launch template here, right? So this is the launch template test script file, and everything related to launch template should be defined in this file. So we can just search the class launch template. Okay, so here now we are in the launch template L2 construct class here, and if we scroll down, there's actually a metadata comment. Okay, so this is where our L1 resource is created here, right? And we are trying to implement the metadata options here. So I will just remove the comments and move it to here, right? Okay, so metadata options is actually a L1 property, so we can simply define something like metadata options, and we actually have some properties to implement. So, and if we scroll up for similar options, actually we have like hibernation options, enclave options. We have some similar options here. And basically all those options is in the top level of the property. We can just simply check if the property is enabled. If yes, then we can just make it enabled like this. Okay, so let's check all our L2 construct properties for the launch template. It's actually defined in the launch template properties. We can just simply go to the definition. Okay. So all the launch template properties are defined here, right? In CDK, we have a convention that we make the properties just like one level. We don't make it too many levels for or in the hierarchy. This will make people easier to to define their CDK constructs. So in our case, we actually have to define 5 additional properties for metadata options, but I will bring it up to the top level in the launch template properties. So in this case, our first property is HTTP endpoint, right? And we are gonna make it a Boolean. Okay, so we're gonna make it HTTP endpoint, and it's optional property. So we have a question mark here, right? And it's a Boolean. and we definitely have to add some comments. So enable or disable the HTTP metadata endpoint on your instance. If the parameter is not specified, the default state is enabled. We can simply remove this statement, and we can declare the default is true, which means enabled, right? And we can add a document link here. Okay, so this will allow users to have a reference link to the original document to see more details, right? Okay, now, and the second property is HTTP protocol IPv6, right? IPv6, and the default is true. Enable or disable the IPv6 endpoint for the instance metadata service, and the default is true, right? I will scroll up and click the IPv6, so I will have the permanent link to this document. Default is true, right? Okay, and the third property is the HTTP put response hoop limit. And it's actually an integer. The desired HTTP put response hoop limit for instance metadata requests. The larger number, the further instance metadata requests can travel. Okay, see the document here. And the default is 1, right? And now HTTP tokens. The state of token usage for your instance metadata request. If a parameter is not specified in the request, the default state is optional. So we just declare our default is optional. So actually, in this parameter, the type is in CloudFormation string, but in CDK, we tend to use something like enum to define different options. For in this case, we actually have two options. One is optional and the other is required, right? Maybe it is possible to have third options in the future. So in this case, I'm gonna define a enum for this property. Okay, and maybe we can just call it LaunchTemplate HTTP tokens, for example. Okay. So I'm not gonna make it boolean. I'm gonna define a new type for it. Maybe LaunchTemplate HTTP tokens, for example. And now let's define the enum class for it. For example, okay, so the first option is the optional, and the second option is required. Right? So now we have defined our launch template HTTP tokens enum here. Okay. So we'll allow the users to have two options to switch between required and options without explicitly define the string for this property, right? So the default value would be option. Default state is optional, right? So the default state should be optional, like this, right? Okay, and now the last property is the instance metadata text, and it's a boolean. Instance metadata text set to enable to allow access to instance text for the instance metadata. Set to disable to turn off access to the instance text from the instance metadata. And the default is disabled. Default is disabled, right? So default should be false. Okay. Okay. So now we have defined all the additional 5 properties we are going to introduce for this PR. And let's just scroll down to CFN launch template here. Okay. So the first option is for the CloudFormation is HTTP endpoint. HTTP endpoint. And we will see if the HTTP endpoint. We'll check if this is defined and is enabled. If yes, this value should be enabled. Should be enabled, right? Otherwise, otherwise we will fall into another condition, right? We'll check if this is defined as false. If yes, then it should be disabled, right? Otherwise, it should be undefined. Okay. So in this case, people can define the value as true or false, or simply make it undefined, and we have to determine if it is explicitly defined as true or false, which means enable or disable. If people just leave it undefined, then we should also leave it undefined for CloudFormation, and the CloudFormation will implicitly set it as the default value, which is enabled, right? But we don't have to declare it as enabled for CloudFormation. We just leave it undefined. Okay, let's go to the second property, HTTP protocol IPv6. Similarly, we just check if it is defined as true. If yes, then it should be enabled. Otherwise, we check if it is false. If yes, then we make it disabled. Otherwise, undefined, right? And let's go to the HP put response hoop limit. HP put response hoop limit. Okay, so this property should be just HTTP hoop, HTTP put response hoop limit, because it's number type. So, but we have to check if the number falls between 1 to 65 to avoid potential error, right? And we will and we will take care of that later. But for now, we just make it just exactly as is. And now let's go to the HTTP tokens. Okay, so HTTP tokens should be props HTTP tokens, right? We actually define the optional and required for the enum, so we can simply define like this. Okay, and the last one, instance metadata text. Instance metadata text is actually a boolean, right? So we have to determine if it is true, then disable, otherwise undefined, right? Okay, that's all. So hopefully this should work, but we have to create a very simple integration testing or very simple CDK application to validate this. So now I'm gonna create a very simple integration testing. So typically we will just go to the test folder to see if there's already any existing integration testing. So in this case, it's actually a LaunchTemplate L2 module. So there could be an existing LaunchTemplate integration testing. I didn't find it, so probably no existing integration testing. So let's find. So let's just create a new integration testing for the LaunchTemplate module, and we can try our new properties in that testing and try to deploy in our AWS account to validate this. Okay, so in the test subfolder, actually all the integration testing start with integ. So I'm gonna create an integ.launch-template TypeScript. Integ. Okay, so in the integration testing, it's basically a full CDK application, but we make it very simple and just test our scenario with the feature or with any bug fix for that. So in this TypeScript file, I'm gonna create just a very simple launch template for EC2. So if we check the instance integration testing, we have CDK application, we have defined our test stack like this, and we just instantiate the test stack in the CDK application and synthesize. So basically we can create a very similar one like this in our integration testing. And instantiate the test stack in the application like this, right? Okay, and in the test stack, we simply create our new launch template. Okay, so this is our new launch template, and so the most important is to check if the new properties we just defined if it is available. So for the first one, HTTP endpoint, right? So actually it's a Boolean type. The default is true, right? So we can simply ignore it or set it as false. Doesn't matter. But I will set it as true here, right? And the second one is HTTP protocol IPv6. I'm gonna set it as true as well. And the third one is put response hoop limit. The default is 1, but I'm gonna set it as 2, right? And the third one is HTTP token. It's also a Boolean type. Oh no, it's a new type. So we are gonna define EC2 launch template HTTP tokens and make it as like for example required, for example. And instance metadata text. Metadata text, we're gonna make it as true, right? Okay. So now we have defined our launch template with just with the metadata options definition here, and we can just simply synthesize into the CloudFormation template and see if the output looks good, just like the document, right? So now we should run the CDK synth. But before that, we have to define our AWS account, AWS environment, everything. The CDK application will check your AWS region or AWS account, for example. Okay, so where is the CDK CLI? So in the repository, actually the CDK CLI is here. It's actually under the workspace, aws-cdk, packages, aws-cdk, bin, CDK. So it's here. So I'm gonna make an alias and point to that CDK binary. So now we have the CDK CLI here. It doesn't matter because it's in the source code repository, so we will not see the real version of the CLI. So now I'm gonna deploy this application, but I will make a split terminal like this and enter and go to the same directory. And I will just run the yarn watch. So yarn watch will just compile all the TypeScripts. It will actually monitor all the TypeScript files, and if there's any TypeScript files being modified, it will just recompile the TypeScript to JavaScript. So in this case, it's in the compilation in watch mode, looking at all the TypeScript. It has compiled the launch template TypeScript to JavaScript. So I'm gonna run the CDK with the JavaScript file. So just run CDK synth and point the application to the launch template JavaScript. Okay, here we go. So this is how it's synthesized to the CloudFormation template. So basically, the CDK application will just create a AWS EC2 launch template resource like this, and we can check the CloudFormation document. Okay, so this is the CloudFormation document for the EC2 launch template, and actually there's a property launch template data here, right? And if we click into the launch template data, and actually we just introduced the metadata options here, right? And yeah, so it's just like string, integer, string. So everything looks great. So we can just deploy this CDK application. So the CloudFormation will just create a launch template resource for us. So let's try it. Run the deploy CDK. The Gitpod environment actually has no idea about what is our AWS account. So we have to define our AWS credentials. So CDK would be able to deploy for us. Okay, so let's go back to the contributing guide and scroll down to the Gitpod section. So you will have to define your AWS SS key ID and secret key ID environment variables. So if you have if you already have your SS key ID and secret key ID, you just define in your Gitpod workspaces, the setting of the Gitpod workspaces. Okay, so you can define the environment variables here for your Gitpod workspaces. Just define the 3 variables in the Gitpod settings. But after you define the variables in Gitpod, you probably will have to restart your workspace to make it immediately work. But at this moment, you can just define your for your current workspace like this. So you can just follow the instructions here to define your AWS SS key ID and your AWS secret key. But for me, I personally prefer not to define static credentials for any ephemeral environment. I personally prefer to define temporary credentials to secure my IDE from any third party. So now I will show you how to define my credentials as with AWS SSO to allow you to simply authenticate with AWS CLI and CDK, so you can deploy your CDK applications with the IAM role federated from the AWS SSO. So I probably will create another video to talk about how to configure the AWS SSO and the AWS CLI V2, for example. But in this video, I will just skip that, and I will just show you how I make it possible with AWS SSO and AWS CLI V2 for my Gitpod workspaces. So AWS SSO only works with AWS CLI V2, but at this moment our AWS CLI is just a V1. So you need to install the AWS CLI V2 in your current workspace. There's actually a document if you are gonna install on Linux, which is our Gitpod workspace environment. So actually I have a code snip to simplify everything. So the snip is very simple, to just define a bash function to install the latest AWS CLI and install to this directory, user local bin, right? So I can just paste this script, enter, and just run install AWS CLI V2. Okay, so now my AWS version should be V2, latest V2 version, right? And now I'm gonna define the AWS config for AWS SSO. So in my personal home directory under .aws config, I'm gonna define my AWS SSO configuration. So depends on different cases, you probably have different but very similar configuration like this. So it's just for your reference. Do not copy paste to your environment. Okay, so now I'm gonna run the AWS SSO login. Paste the code. Allow. Okay, I can close the tab and just go back to my VSCode. So now I have successfully logged into the AWS SSO start URL. So I can check my current identity with AWS STS get caller identity. Okay, I'm authenticated as the administrator role here, right? So now I'm good to deploy the CDK application with the federated role from the AWS SSO. For all the CDK deployment, I will always recommend to run the diff first. So CDK diff tells you that what's gonna what's the difference between your current deployment and your last deployment, if any, right? So if you already have any existing deployment, it will just compare the difference for you. But if this is your first new deployment, it will just tell you so what resource is gonna create it. So in this case, we just create the AWS EC2 launch template, which we just defined in our integration testing, which we just defined here, right? Okay, so looks good to me. Let's just deploy. Okay, so at this moment, we can just go to the CloudFormation console and see if the CloudFormation stack is being created. Okay, let's go to the CloudFormation console. Okay, so this is our test stack. Okay, so the test stack is actually the stack ID we defined in CDK. So if you go back to your CDK integration testing, so it's here. It's the ID of the stack. So the ID will be the CloudFormation stack name here, right? And if we click the resource, so actually we have the launch template created here and created complete, right? We can just click a link and check out the launch template we just deployed. We can scroll up and check some details about it, right? So it's basically all the properties we defined in our L2 constructs, the launch template constructs, and looks like it works as expected, right? So keep in mind that it is always your responsibility to deploy to your personal AWS environment to validate if it really works. Because as a contributor, we have the responsibility to validate our everything around our PR, and to check all different cases to make sure that our PR is good and safe for different cases. Okay, so now we have the EC2 launch template, right? So EC2 launch template is basically for like auto scaling group or EC2 instance. So if you are interested, you can make it a little bit further to test it with an EC2 instance or auto scaling group to make sure that it really works with any EC2 instance or auto scaling group. For now, I'm not gonna show how to create EC2 or auto scaling group with launch template. If you are interested, you can just give it a try and make sure your launch template always works with EC2 or auto scaling group. So for now, it looks like our PR is good. So you can simply submit your PR as a draft PR. So the draft PR is something that tells the maintainer that the PR is still a work in progress and you are still working on it for some additional like testing, unit testing or integration testing. It is fine at this moment to just submit your PR as a draft. So now I'm gonna show you how to submit a draft PR for this. Okay, so let's go to the source control panel. AWS CLI V2 zip, we can simply remove the zip bundle. It's for AWS CLI, so temporary directory, we can simply remove it. So basically, we just create two TypeScript files. We just update two TypeScript files. The first one is launch template. The second one is the integration testing, right? Okay, so we can simply make a commit. Okay. And now I'm gonna publish to my personal GitHub fork. So I will just check out to a new branch from my personal GitHub fork. So I just go back to the CDK repository and just create a new fork for the AWS CDK. Okay, now I'm gonna create a fork for myself. Okay, so now I have a fork in my personal space, in my personal namespace, right? And now I'm gonna create a remote for my personal GitHub repository. So this is my personal GitHub repository for this fork, right? So we can go to the code and copy the HTTPS source for this repository. So this will be our personal remote. I'm gonna push my code to this remote fork under my personal namespace. I'm gonna create a new remote for this and call it, for example, Pahu, my name. Okay, and if we run the git remote, so now we have origin and Pahu. So I'm gonna push to my namespace for this PR. Let's just push to this remote, which is in my personal namespace, right? Okay, so actually we have pushed our code to our forked repository in our namespace, right? You can simply click this button to compare and create your pull request. So I'm gonna click this here, and now we are in the AWS CDK repository. We are trying to open a new pull request, and for the PR description, we have to describe the PR and link to the issue we are trying to resolve, right? Okay. And because this is a feature improvement, so we have a semantic syntax for the PR title. We have to define this PR as feature, and this PR is for AWS EC2. So this is our convention to define our title for the PR. And because we are still working on it, just create this as a draft PR. Just click this button. Okay, so if you see the gray button draft like this, so the maintainer will know that it's actually a draft PR and you are still working on it. Okay, now we have submit our PR draft. Follow all the guidelines in the contributing guide, as well as check all the checkbox here, to make sure that it's a complete PR, including the integration testing, unit testing as well, and follow all the guidelines in the contributing guide. Okay, so if you scroll down to the CDK automation bot, the comments from the automation bot, okay, so actually this is a feature update. So all the feature update will require the README update. So we are gonna cover the README update later. We can just submit the PR draft for now, but definitely we have to comply with all the guidelines, including the README draft and the integration testing, to ensure that the PR is good and ready for review. And we are gonna cover those in the next section. Okay. Hi everyone, welcome back. So it's been a few days since I submit my PR draft last Friday. Actually, I was in New York at home, but now I'm traveling in the hotel. So let's continue the PR. So today, I'm gonna open the PR draft with Gitpod, and the Gitpod will create a new workspace for me. Let's click the Gitpod button. Okay, so what's happening now is Gitpod is creating a new workspace, and everything will be pulled down in the workspace so I can continue my development. So make sure that if you are gonna stop your development, always commit and push to your fork. So next time you can just open with a new Gitpod workspace and continue your development. Okay, we are in. So what I'm doing now is open the remote Gitpod workspaces in my local VSCode. Okay, so now we are in the local VS Code, but the workspace is on remote Gitpod workspaces. So every time you create a new workspaces, remember you have to reconfigure your AWS CLI, because we always install the new AWS CLI and it is not committed to the repository. It is just a post installation for these workspaces. So make sure you always do that. So if you check the AWS CLI version again, it's actually V1 at this moment. So let's run the V2 again. So this time I'm going to the temp directory. This is my install AWS CLI V2 script. Okay, V2 installed. AWS version. Okay, it's V2, right? Okay, and we still have to update the AWS config. Log in the AWS SSO again. Okay, I'm in. Okay, good. So now I'm ready with AWS CLI, and I need to make the alias for the CDK. Okay. So now let's go to the EC2 module. And let's check out our integration testing tests. integ.launch-template TypeScript. Okay, so it's actually not really an integration testing. It's just a full CDK simple application with the new properties we introduced for the EC2 launch template, and we just run it in our environment to make sure it's working right. But for the integration testing, we need to look at the integration testing document at the CDK repository. This document in AWS CDK, so it's under AWS CDK integration tests markdown. So what is the CDK integration tests? So you have to read all the document. For the existing L2 constructs, we need to add the coverage for all the new properties. So we just introduced the 5 properties, right? So we have to cover all the 5 properties. And basically the integration testing looks like this. You have to import the integ class from the AWS CDK integ tests module and pass the stack to the integ tests, right? Okay, so I'm gonna run this for the integ.launch-template.ts, but I have to compile the TypeScript to JS, right? So I will run the YAML again in the EC2 directory. So YAML will compile everything TypeScript to JavaScript in the current directory. Now let's run it. So what's happening now is that it's deploying this integration test to my AWS account in US East 1. And after the deployment, it will just CDK destroy and delete the stack, and then generate the cloud assembly to a snapshot directory. So let's just wait a few minutes. Okay, not bad. So now we can run the npm test or YAML test to compare the snapshot. For example, I'm gonna run the npm test. For example, I'm gonna run the YAML test or npm test. Basically, the command will just trigger the CDK test. So in fact, it will. So this might take a while because it's gonna run all the tests under the AWS EC2 directory, and there are quite a lot, and there are quite a bunch of integration tests. Okay, look good to me now. If we look at the launch template integration testing, so it's unchanged. So unchanged means that this application basically synthesized into exactly the same snapshot. So nothing changed, which means good. So we have the confidence that the integration test is okay and ready to submit. So if you click this button, so this is everything the young integ generate as the cloud assembly for the integration testing. So let's commit everything. Okay, so now the integration testing is ready. Let's create a unit testing for this PR. Just go to packages, AWS CDK, AWS EC2, and test, and scroll down all the way to the launch-template.ts, right? So this is the existing unit test for the launch template. So because this is not a new L2 construct, so obviously there are already some existing unit tests. So we just create a new unit test in this file. Okay, so this is my unit tests for the launch template metadata options. So basically I create a block for all the tests for the metadata options. So describe launch template metadata options. So basically it's everything around this feature. Okay, and I have a loop to check each properties. For example, the first one, HP endpoint, I would check both true and false, and see if I can expect the expected string as enabled or disabled in this case, and check another case for HTTP protocol IPv6, and so on and so forth. The most interesting is that I have to validate this property HTTP put response hop limit, because this property should be an integer between 1 and 64. So any integer less than 1 or more than 64 should be invalid. And if we look at the source code, we actually have an annotation for this case. We actually have an annotation to detect this arrow, but we have to pass all potential values to check if we can capture this arrow. So this is this is the trick to capture the arrow from the CDK stack. For example, if the given number is 0, so we should have one arrow. So the arrow length should be 1. We will have one arrow detected. The expected 1 means that we will have one arrow detected. Okay, so this is so they are all invalid. And 0 means that we will have no arrow detected. which means that the value is valid. Okay, so this is the trick for the validation of the this property. Okay, so if everything is good, come back to here and we can commit our integration testing. But before that, we have to run the YAML test. And make sure you have YAML watch running, always running in the separate terminal. Okay, let's do it. Okay, we passed all unit tests, right? And integration tests all unchanged. So now we can commit our unit tests. Okay. And last but not least, we have to update the README. So let's go to the README of the EC2. README. Okay. And look for the launch template. Okay. Okay. Now we can commit the README. Okay. So now we have integration tests, unit tests, and README update, right? And let's run another command, aws-lint. This will check all the potential linting error message, if any, so we can fix it before we submit the PR. So in this case, we need to define a default property. Okay, so it's a typo. Okay, let's fix it and run the aws-lint again. Make sure the YAML watch complete before you run any command. Okay. Okay, we passed the aws-lint. Now we can commit the minor change. Okay, let's push to our branch. Okay, let's check the PR. So we have pushed all our commits, and this just triggered another GitHub action workflows to validate all my PR. And this will take a few minutes, so we can just make sure that it passed all the checks. Okay, so after a few minutes, we got a build error from the CI. So it's a CodeBuild error. So we can just click the build log and scroll down to the bottom and search the error. Okay, so this is the auto-scaling module. So it looks like we just broke the auto-scaling integration testing. Okay, so the auto-scaling integration testing actually does not define the metadata options. So if no metadata options is defined, we should not add the metadata options property, right? So we have to fix this error. Let's go back to the our integration testing. So let's check out our integration testing. So I'm gonna synthesize the check the output. I'm gonna just check the output. So this is our synthesized CloudFormation template. So let's see if we just ignore all the properties. And in this case, we should not have the metadata options property. Okay, let's do it again. Okay, but we still have the empty property here. So this is where broke the integration testing of the auto scaling group. So we should fix this error, right? Let's go back to the launch template. Okay, so I define a private method as render metadata options to render the code block for the metadata options. So if all the properties are undefined, then this will just return undefined, which means that metadata options will be undefined. Otherwise, any of them, if any of them is defined, then we can just refine the code block like this, and we just render the code block with this private method. Okay, so now let's run the synthesize again. Okay, so there's no metadata options, which is good. And let's enable this and try again. Yes, we got metadata options. Okay, so let's run the young test again and make sure everything is still good. Okay, good. Run the AWS lint again. Good. So we can commit the changes. Okay, so the CI is running again. Okay, so we just passed the CI. So if we scroll a little bit up, the CodeBuild CI report result is succeeded. Okay, so now we can click this button, ready for review. Okay, then we have the green open PR, and we can update the PR description here. Okay, that's all. So I hope you find it useful to help you to get it started from a very beginning of a key PR contribution from an issue to complete the PR, including the unit testing, integration testing, and README update. I think this PR might need a little bit iteration, but we'll wait for the maintainer, the core team, to take a look. So if there is any suggest changes, then I will follow up and complete the PR, make this PR merge. Thank you for watching this video. We'll see you next time. Bye.